I'm Tom.
I'm Case.
I'm Meredith.
This is the Rainflute
2.0.
2.0, yeah, I guess. It kind of slimmed it down a little bit, to say the least. This proved kind of cumbersome. And the concept basically is it's a one-stringed wind instrument with a rain stick built into it. Yeah, you've got this ribbon to control pitch continuously. And then you have a breath, like a pressure sensor mounted in here that you control with your breath, and that triggers note-ons and also aftertouch during notes. Then we have an accelerometer mounted in this like rat's nest in here. Like when you tilt it, you kind of trigger sort of ambient accompaniment to the sound. The amount that you tilt it controls like the rate of sort of like the rhythmic aspect of that ambient sound. Oh, and the button, so that controls the patches. We have 4 mounted here, but only 2 of them are working right now, which is fine. We just have it cycling through 4 different patches for each aspect of the sound. For the melodic sound coming from breath and the ribbon, and then from the accelerometer, whatever ambient noise. It's like a little 8-pin chip in here that is basically just hot glued to the end of this tube. And the amount of hot glue we used was like we tried to get it so that there was still some air flowing through, so you had some resistance, but also not too much. So it kind of felt like playing a wind instrument.
We tried to use a recorder mouthpiece
Right.
to make it just seem more like a flute, both in appearance and actually how it feels when you put it to your mouth. But we had problems with the airflow because we had to plug up that hole so it didn't whistle when we played it. And after doing that, we found that this whole area is not one open air chamber, it's just like one narrow air chamber, so that blocked it up completely.
And we adjusted the sensitivity down at the bottom, and also there's a threshold that is where you start the pitch.
Probably the most important addition is there's a strip of RGB LEDs all the way up and down.
We'll get to that later.
This is like a 3-zone ribbon, so when I go up and down this is like this is like the minimum, and then this is the maximum for that range right here, and then we have this middle range right here. And it kind of like if you plot like the voltage as you go from this end to this end, it kind of goes like up and down like that. So we had to do just a little bit of math to get it in the right range. To format it as like a 2 byte pitch bend message. There's a 10-bit value here, 10-bit value here, 10-bit value here, and we just want to take that and get something from 0 to 127. Like when we start here, it should be 127 basically, or it's close anyway, it's 122. And when we go down here, it's like 1. You can toggle between discrete and continuous pitch basically. You can have it be in the chromatic scale, and the way to accomplish that is basically just divide, round, and multiply. You have this like a threshold value, and you want to only trigger a note when it gets above that threshold. And in this case, it's a pretty low, but like basically you wait for that threshold and then you trigger a note on. And once it falls back down below it, you trigger a note off. And in between, you have aftertouch going to the patch, so you can control things like the amplitude. So you have it maxed out, and you also have this tilt to a certain amount.
Goes into superhero mode?
Yeah, basically. Once you tilt it a certain amount, you trigger one of these patches. And as you tilt it more, you control the rate. We wanted to use like the LFOs in Maelstrom to kind of have some rhythmic aspect to the sound that could have a varying rate.
But we have just the 4 subtractor patches. They're the 4, I guess, breath patches that emulate the flute sound. They were sounds that are kind of a combination of a traditional flute sound and an electronic character as well. And then again, pitch bend in max, controlling pitch bend in reason, set the range all the way up to 24. And then we had our maelstrom patches. We're controlling the, I guess, the rain stick sound. And like Tom mentioned, they're just controlling the modulation rates
Yeah, you can see that.
in sequence. Yeah, they're tied together. In the combinator, they're all just mapped out to a few discrete notes.
Right.
So when we're doing the patch change, it just changes the note.
There's like 32 RGB LEDs running up the body of the instrument, and so as you blow into it, you get these blue LEDs traveling up with the instrument, kind of, and the rate is proportional. It was, first of all, the brightness is proportional to how hard you're breathing into it, and the rate is proportional to how much it's tilted. So as I tilt it, so another thing that happens, which you might have seen for about a second, when it's tilted a certain amount and you're blowing it at the max, you, like, it just, like, the lights just, like, freak out. They just randomly cycle, like. Yeah, that's my favorite one. Because when you get down there,
Yeah.